Welcome at the Masters of the Code channel. In today's video I want to show you some Influxdb queries, and to be more specific, the 4 versions of the one query. The least optimized to the most optimized with additional conditions. And the reason why I've chose to make that video is first, I've tried to Google the solution and I couldn't find the perfect solution for me, because it's always like that. There are some simple solutions. Even in Influx documentation you can find some simple examples of each function, but you can't find some advanced queries, some advanced examples, and it's the same on Google and YouTube. So that is why I want to share with you with a real life example, and I will show you it as the example of my photovoltaic installation. So let me remind you about some basic assumptions really briefly. So I want to put on graph the production, so the energy generated by the inverter, about the export to the grid, and the energy imported from the grid. And those 3 measurements are kept in cumulative registries. So it means that value of those registries will grow in time. So for example, if I would get the value at 11 hour, for example, and then if I would get the value at 11 hour 10 minutes, I would get the greater value with addition of if it's for example for the production registry, with addition of that energy produced by that 10 minutes. I will also need the SSH session to my Raspberry Pi 4, which is hosting the Influxdb and Grafana. I will also use the qewrite from the KDE when I have all 4 queries, and also I will use the browser with the admin interface for the Influxdb when I will create some test bucket for that purpose, and I will copy the data from my, I would say, production bucket here, and the Grafana I will use the graph for presenting that. So here you have the example what we are trying to accomplish. So I will edit that graph, and I will put here those queries to show you how it works. And also I'm in that perfect situation when I have the real data, and I've also prepared some 10 years period of random data, so I'm able to show you how those 4 queries differs in performance. So you can see here the first query. Those 3 lines are responsible for calculating the diff coefficient, and it's needed because we have data in kilowatt hour units, and in shorter periods of time, like for example 5 or 10 minutes, we need to multiply those data to be able to get data in watts or kilowatts units, because we can't just put the kilowatt hours value in shorter periods of time. So how it's done? We need to calculate that period 1 variable. We are checking the condition. We are adding 5 minutes period, and it's 5 minutes because we have the minimal period in the window. The minimal period is 5 minutes. So we are adding 5 minutes to range stop time date, and we are checking if it's greater or equal to the time range stop. With addition, we are adding here the actual window period. If it's greater or equal, we need to apply that minimal 5 minutes period, and in the other case we need to put here the real window period. Then we are calculating the range duration in seconds. So we have the time range stop and time range start. we need to convert those values because those values are kept in time type in Influx. So we need to calculate, we need to convert it to uint, its integer value. So we are converting to uint integer values. When it's converted, we can subtract the range stop and range start. So we have the difference between those two timestamps. Then we need to divide it by 1 million and by 60. So then we have the difference in seconds here. And then at the end, we are able to calculate that diff coefficient. We are calculating it you can see it here. We are checking if that time stop plus 5 minutes is greater than the window period plus the time range stop, and in that situation we can assume that we have that minimum 5 minutes period. So we need to divide the 60 by 5. If the window period is greater than 5 minutes, then we need to check if that range duration is less than 60. So if we have that duration less than 60. Oh, and one correction, I've said if it's in seconds, but it's in minutes here. That's range duration actually. So if it's less than 60 minutes, then we are calculating the coefficient like that. We are dividing 60 by range duration, and if it's greater than 60, so we have the period greater than 1 hour, we don't need to actually do anything. We are putting 1 here in that diff coefficient, because later in that query and all of those query, we are applying that diff coefficient to recalculate each measurement, so production, import and export. Later we have the actual queries, and in the first version we have 6 queries. So we have the 2 queries for each measurement, and one of those 2 queries is with the offset of that window period, and one is without that offset. And it's because we want to calculate the difference between each pair of points, so between the next and previous one. So we are doing that kind of query for each measurement here, and then we are using joining to join all of those measurements together. And in the Influx we are unable to join it all at once. We are only able to join 2 queries together, so we need 5 joins in total here. So we are joining each pair for each measurement, the normal values and the shifted values, and then we need to join the export and import, and at the end the production with that export and import join. You can see here in the map that we are subtracting those values, so we have that normal value and the shifted one for each measurement, and we are able to calculate it here for each point. Then we are applying that diff coefficient, and here, because we don't have the easier solution for Influx to round values, we are multiplying by 100 and dividing by 100, so that way we are able to round that value with precision of 2 places. And then we are doing additional checks needed in the situation when we can have some slight differences, because we when we are gathering data can have some slight differences between, for example, production data and import and export data, and sometimes those values can be incorrect. So we are doing some sanity checks to show those values in that kind of situations on the graph nicely. Right now I'm going to copy and paste the first one query here, and we can see how it works. it's a wrong query, so I will reload it. It's wrong graph, so I need to edit that one and paste it here. So you will see the same results here from the from that query. That's the idea. But what I'm trying to show you is the performance of that query on the long ranges. So let's apply here some longer range. I will jump to 2011, for example, April 1st, and then I will jump to the 2019 April 1st, and I will apply the time range. And in that case, you will see the timeout in the Grafana because we are not able to complete the whole Influxdb query in specified time. And the difference is really huge between those four queries, especially in between the first one and the three other ones. So we are not going to get any data. As you can see here the context deadline exceeded error. So let's get back and see the second query. So the second query, it's still not optimized. It will use joining method only, but it's optimized for code quantity, and it should get the result in the Grafana. It's optimized in the way we need only 2 queries instead of 6 queries like you could see before. So the difference here, we have the same stuff to calculate that diff coefficient, but the difference you can see here is in the filter. When we have all 3 measurements put to the filter for the ordinary query and for the query with the offset for the time. Here is for the offset and here is the regular query. And to calculate those specific measurements, we are applying a filter one more time. But the database engine in that case needs to get those data only once, so it should perform better, and then we are able to just filter for each measurement, and we still need to put 5 joins to get data and do the rest of the calculations. So let's copy and paste the second version and try to run that query on that long period of time. You can see it's much faster in that case. It returns data, but of course in that case, for that longer period of time, we have that situation. It's the issue inside the Grafana when you are normally not able to view more points in the series. We could change that stuff in Grafana, but it's not related in to the Influxdb query. Let's jump to the next query here. The next query doesn't rely on joining for calculating each point, so to calculate the difference between the next and previous points. That query uses that derivative function, built-in function to the influx, and I don't remember the correct name right now, but you have the same pretty the same function but without the unit here, and that function will also calculate the differences, but the derivative function will also scale values nicely in the cases when you have, for example, gaps in some data range, because if you want to calculate with the specified period, for example 5 minutes, if you have all the data, it's quite simple. So you calculate the difference between next and previous value, but you have the problem, the issue occurs when you have a gap on or some, for example, issues with gathering data from the equipment. So when you have some non-standard periods in the data range, for example, you assume that it's 5 minutes, but in some points you can have 10 minutes. So in that case, if you wouldn't been able to scale it here properly, those data would be presented incorrect, because you would apply that diff coefficient which is calculated, for example, for specified period like 5 minutes, on the two different points in some cases, which are gathered for different period of time, like 10 minutes. And when you use that derivative function, it handles it for you nicely, so you can use that diff coefficient and the output data is correct. When we use that derivative function, we also don't need that second query, so we only need one query to the database. We don't need that map function with the normal query, we just need that one, and we are also using map with period of time subtracted for each value, and that one is needed for presenting it nicely on the Grafana graph, so the points are starting from the exact left side of the graph window in Grafana. Then we need to just put the filter, but only once in that case for each measurement, and we only need two joins here, as you can see, and the rest of the query is the same. So let's try that query in the Grafana right now. I put it here. We can even try to put some other higher value here, and as you can see in that query you have additional performance benefit, because when I've done it for the previous query, it had been faster than the first one with so much queries, so 6 queries, but not as fast as the third one. So in that case, even when you put the more data points in the Grafana, and even if it's rather issue in Grafana when you are not able to graph it nicely, not in the Influxdb, for the third and fourth query it will work like expected with no issues here. Let's get back to the queries and let's check the fourth query, and after showing the fourth query in the Grafana, I will also show it at the separate bucket, because I want to remove some measurements to show you the additional benefits of that fourth query. And in that fourth query we have the same approach, same benefits as in the third query, but here we are additionally adding some conditions, because we can have the situation like that. You have the inverter and the separate power meter like Istron, for example. I've already showed you in my previous videos, and you can have the situation if the inverter doesn't use the vendor built-in meter solution, that inverter will shut down where there is no irradiation. So for example at night, and if you have a shutdown inverter, the Influxdb loader service won't collect the measurements for the production at those ranges where when inverter is shut down. That is the issue, because you don't have that measurement, and it's the issue in the join function, join method in Influxdb, because in Influxdb you have only the inner join, so it's not the outer join. You can do that, so it's the inner join. And if you have if you lack some parameter in the whole range, it won't work, and it won't show you the other measurements in that case. And you can also have the situation when somebody uses only inverter without any power meter, and in that case you don't have the import and export measurements, and the use case here is you want to have the single query for all those situations to handle all. And to prepare such query, I'm using here conditions, but conditions not only for calculating the raw fields for measurements, for example, but also the conditions in the places when I need to decide how to process queries. It's I would say it's not usual usage of those conditions for InfluxDB. As you can see here, I'm gathering data. Then for the export, I have the situation when I have all three measurements, so production, import, and export. So in the export exp1 for export, I'm assuming that, but I'm also preparing the exp1a for the case when I don't have the production values. I don't need to cover case when I have only import or export, because it's not the real case. I have only situation when I can have all three measurements, only the production, or when I have the import, I will have also the export, because it's from the same equipment, from the power meter. So if the power meter is present, it will deliver me either both values or no value at all. I'm calculating that exp1a in the case when I don't have production, so I will put at each point the 0 for the production, and the same way I calculating the imp1, but I don't need to calculate and put the imp1a here, because it's always paired with the exp1 or with exp1a. For the production, I do the same, but in case I don't have import and export, I put in prod1a the 0 for import and export, and then I'm using that function to find record, and I don't want to filter anything, so I'm putting true here, and I only need the first row, first value for each measurement with the index 0, so you can see the IDX0 here, and I need to only check the beginning of the range. So we have the test for import, export, and production, and then we are preparing the joins. So the J1 is the join between export and import, J2 is the join between export and import in the situation when we don't have the production, because it uses the exp1a. The O is the join here between the production and J1 when we have all three measurements, and we don't need any joins when we only need the production, so prod1a. And here is the most interesting stuff, so it's the conditional expression to process those queries. So we are assigning to O based on the tests of the export and production. So when the first value for export and production exists, we can assume we have all three measurements. We can put the all here and assign it to O, and else if we only have the export, we can assign to O the export and import join here, the J2, and the last case is we only need or have the production data, so we are assigning the prod1a. And because we have those value covered in this situation, we lack all three parameters before, we can then process it in the standard way. So there is no difference in processing when we have different situations. And also you can see that additional conditions here, I won't cover it. It's quite simple because it's needed if we, for example, don't have the export values, so we don't want to show the consumption, and for example when we don't have production, we don't want to show production. In that case we have 0 on the graph. So right now I will put that query to the graph enum. As you can see, it works correctly. So what I'm going to do right now is create new buckets. So I will go to buckets and I will create the Fusion test bucket, and when I have the Fusion test bucket created, I can populate it using Solar Fusion bucket. I need some measurement here, and I need to put submit here, script editor, and right now I don't need to filter anything. I want all measurements here, but I want it for specific range, so let's put conversion to time here, and I will put 2021 May 22nd, for example, midnight, and I need to put the range end also. Let's put 25, for example, on 24 here. I will use 2 to specify target bucket, fusion test, and also target organization, infinite energy. And let's click submit here. Okay, so we have the fusion test populated. I will open it in the separate tab, and as you can see we have some values. So let's check the accumulated yield energy and grid accumulated and exported energy. Okay, we have all three values in that range. What I want to do right now is to replace the solar fusion bucket in all queries to fusion tests. So let's replace all, and right now I can even take the third query to query that specific range. So I will put that query to the Grafana, and we will query that fusion test bucket. We need that specific range, of course. So 2021 May 22nd, and we will query to the 24th. Okay, so it works, and we have every data here, as you can see. But what about the situation when we don't have all measurements? So, for example, right now we can remove the grid accumulated and grid exported energy. I'm doing that in the for loop in bash. I'm also removing some other parameters, so we will leave the production actually here, and we will use the influx delete to accomplish that at the fusion test bucket, and we can try to query it one more time. The interesting situation is, as you can see, we have only production here, and we have all measurements in that range here before, because I've deleted it only in some specific range. So here we have all three measurements, but the interesting situation will be if I switch range to the range when we don't have that export and import. So let's do that, and you have no data for that third query, as you can see. And if I switch that query for the fourth one, you will see that the fourth one will cover that case nicely. Let's see. As you can see, we have the production only, and no consumption, no self-consumption, and it's because we have those additional conditional expression here for covering it. So as you can see, it works correctly. That's it for today. I hope you enjoyed it and it's quite useful to you. Remember to subscribe my channel, hit the thumbs up, like my video. Thank you for watching. Bye.